Okay, let's start with precision and accuracy. Basically, the concept of where random error and systematic error comes from. So, say for example, we give. Um, uh, have you seen those Robin Hood challenges and stuff?
কিরকম আই থিঙ্ক নাম হিসেবে জানি না বাট বললে মনে বুঝবো
I don't know. It's they have this target,
বুলজাই মারতে হয়
and basically
ডার্ট বললেই তো হয়
darts. Okay, fine. And yeah, you have bullseye. So this is say a target. Oh man, that's an ugly target. And we have someone with a bow and an arrow who wants to shoot arrows, right? So they shoot arrows and they hit the target. What?
arrow to the knee joke.
Oh man, too much Skyrim. Not the structure of the atom, but yes. So now, say I give you a bunch of arrows, and say you're really bad at archery. So what's going to happen? What's going to happen? Other than the fact that you might shoot someone in the knee, what else can happen?
I don't think I might hit the bullseye or the board itself.
Okay, so there's a possibility that when you fire arrows, shoot arrows, right? একটু ভালোই একটা scatter থাকবে, right? Like, it might be
একই
something.
জায়গায় হওয়ার চান্স
Something like this, right? So this is basically a representation of being what? Imprecise. Take us, you're over a range and everything. So compare that to someone who's very precise. Take us, someone very precise might do this. Even though this is precise, they're all hitting the same place or almost the same place, but not the bullseye. Take us. And let's take another possibility.
someone who's accurate.
Someone who's this, right? All of them hit here. And let's take the third possibility, which would be someone who fires like this, who's almost around the bullseye, but his average would be the bullseye, but he's all over the place, right? So these are the four possibilities. So could you tell me the four different possibilities that we got here, what would they represent? Oh, by the way, guys, Mugdho is a grade 10 student, so he's never seen any of this stuff. So, even if he's wrong, it's not a problem, and I believe he's smart enough to actually pick up the correct answers. So, yes, the red one. Well, let's start with the easy ones first. What do you think the blue one is?
The blue one is precise.
Precise, correct.
Not accurate.
Excellent, man. You're pretty smart. Precise, but inaccurate.
That's right, inaccurate.
Or not accurate, that's absolutely fine, right? What about the orange one? What do you think the orange one is?
That's both precise and accurate.
Excellent. Precise and accurate. What about the green one?
The green one is
It's all over the place.
not precise, but it's accurate.
Imprecise,
Imprecise,
but accurate. And what do you think is the red one?
it's nothing.
It's nothing. Correct. It's imprecise
And inaccurate.
and inaccurate. So, yes, why is the green accurate? The green is accurate because even if you do an average, it's going to come out at the same value, right? So now what we're going to do is we're going to go a little faster. We're going to apply this concept into different concepts of physics. So, for example, say a true value is, say, the length of a string. Take a say, length of the string is, say, 10.1 centimeters. I always write 10.1. I don't know why I do that. So, এখন, say we give this string to a bunch of students to measure, and they come up with different variations in the value. So say a bunch of students come up with values which vary from say 8 to 11 centimeters, right? That's one bunch of students. Then we have say another bunch of students who ektu beshi fazil, so they came up with say 12 to 22 centimeters, right?
Okay.
Do you have any names in mind? And then say another group of students got 9.8 to say 10.3 centimeters, right? And we have these really smart bunch of kids who got say 6.1 to 6.2 centimeters, right? So these are different sets of values.
Achha.
So what do you think each one is here?
I think 9.8 থেকে 10.3 that might be
Precise and accurate. It's
Precise.
precise. Okay, let's use a different color for this. Let's use black.
Same color.
Precise and accurate. What about 6.1, 6.2? What is this?
That's
It's precise,
but not accurate.
Precise and not accurate. And then what about the other one? This one. What is this?
You got the 12 to 22. That's nothing again.
It's imprecise plus not accurate.
Not accurate.
And what about this one?
This is accurate but not precise.
Yes, because we can have a closer, smaller range, which is even better. So this is going to be basically imprecise but accurate, right? So I guess you're getting the idea of this. So we can show this in a slightly different way also. Say the same thing, measuring strings and stuff. So the same thing that we have, we can show it in a bunch of graphs. So say it's a distribution graph, so the number of readings that you get versus the value. So say this is the true value, right? So you can have a graph which is like this. So basically the true value falls within the range that you're measuring. So that means what? This is accurate, right? Now let's compare this with another graph that we draw here. Say something which is like this. They're both accurate, right? Because they're both within the range. Which one is more precise?
The one that's narrower.
Oh, yes, the blue one, right? Because it's a smaller range, right? So that's basically better precision than the other. All right, now let's look at a different scenario. Say this is the true value, right? So say we have a range of values which go here, huge range, right? And this is on the side. And say we now have another set of values which are here. They go like this, right? So what would you say about these two?
So the blue one is
Precise.
precise
Yes.
but not accurate.
Inaccurate. What about the green one?
I think that's accurate because it includes the true value.
Excellent, man. A lot of A-level students actually make this mistake saying that T is inaccurate. Good job, good job. I'm proud of you. So T is actually accurate because it's within the range, right? It's like saying the value of G is somewhere from 1 to 100. So even though that's a very skewed set of values, it is actually between 1 to 100. That is the correct way of actually representing it. And the range is big, right? Neshlihan, you're late. Very, very late. Like, you're here at almost the end of the class, which is very unfortunate. All right. So yes, moving on. Okay. Now, another interesting thing is these things happen because of two different types of errors. There's this thing called random error. And there's another thing called systematic error.
What about human error?
Yeah, we'll talk about that too. Okay. So random error and systematic error. So say for example, the reason we got a bunch of different values, even if we gave the same string, and you see how I said that a bunch of students got between 9.8 to 10.3, right? So what does that mean? That means there were a number of students who took this reading, but different people got different readings. What was the reason for getting different readings?
The instrument error hite pare.
Well, measuring instrument error theke beshi, it's more like the technique itself. For example, parallax.
Parallax, okay.
Right? Parallax error. So different people will get different variations in the reading, right? What else could you say is random error? Do you have any ideas what random error could be?
No, but
I'd put reaction time here, wouldn't I, Nikki?
Also in general. Reaction time
Yes, we could
kotkhon
put
lage to start a stopwatch or something.
But so is reaction time systematic error or random error?
I think it's.
Let's ask this to the students. What would you do with random error, with reaction time? Would you put it in random error or would you put it in systematic error? Think about that, right? And what else do we have? So random error, if you start to build a concept around it, random error is basically an error which causes a scatter of the values. All of the values don't have the same error. Some will be more, some will be less, but that's basically random error. And it's basically due to faulty technique. Okay. What about systematic error? How do you think systematic error is going to be?
I think it's something that an error caused not by anything by a person
but the
itself.
system, right?
Yeah.
Basically a faulty apparatus. So one of the most common systematic errors that we know of is this thing called zero error. Can you give me an example of zero error?
ওই যে ম্যাথের এখানে দেখা যাবে জিরোর একটু বেশি থাকে বা কম থাকে
Basically, yes, when you stand on a balance or you put something on top of a balance, sometimes it's not exactly at zero.
হ্যাঁ একটু
Ammeters-
কমে রাখি আমরা to feel better.
Exactly, yes, to make ourselves feel happy about it. So that's zero error. So zero error is another sort of error that causes some sort of variation in the value. So, for example, if we were to start plotting graphs from these, what would you get? So, say I plot a graph, right? So, this is supposed to be the answer. What will random error cause to the graph?
ইকুয়ালি উপর ইকুয়ালি নিচে
So, what do we call that? Scatter,
scatter.
right?
Okay.
So, random error would be seen in the graph as a sort of scatter around the graph, right? And if you had a graph having systematic error, what would you see? The graph which is supposed to pass to the origin
Does not.
does not pass to the origin. You'll get something like this. And what's the logic behind this?
Which
Logic
is
is
zero.
basically all of the values have actually shifted by the same amount.
Because the apparatus itself
Yes.
has the
So that can be caused by a zero error. And there is another error which can cause it, which is going to be called calibration error. Calibration error is basically, say, all of the values are coming in slightly more or slightly less, right? So that's basically a sort of systematic error due to it. So we're still left with reaction time. So what do you guys think? Is reaction time systematic or is reaction time random error? Let's see who can come up with a convincing answer.
could I try?
Yeah, sure.
It might be random because কেউ একজন একটু আগে ছাড়তে পারে কেউ একজন একটু পরে ছাড়তে পারে. Let's say it's like I don't know, a balloon lifting up from someone's hand আর সিলিং এ কতক্ষণ টাইম লাগে. So someone একটু বেশি এক্সাইটেড হয়ে let's just say আগে চেপে দিল আর someone একটু আইলসা ও একটু পরে ছাড়লো.
But then again, what about saying that everyone has the same delay in reaction time, and also part of the fact that you are being part of the system? Would that make you random or systematic in error?
So you're saying
I'm not saying anything.
Acha.
I'm not saying
so the
anything.
person who is doing the experiment himself is part of the system, right?
Huh? Yes.
Because ও তো অ্যাপারেটাসটা চালাতেছে.
So what could it be?
I think it would still be random.
Are you sure? Are you sure about that?
Yeah.
Let's see what our students say. Oh wow, we have two very contrasting points altogether at the same place. Random time is random error because different people have different reaction times. And systematic error because it gives a constant error either below or above true value? Question mark. Replying to your same individual have different reaction times as well. So yes, do you guys go with random or systematic? Come on, anyone coming up with a convincing answer will be part of what we're going with. Let's keep this open, right?
Okay.
Whoever sends the right answer, the first, a full comprehensive answer, either in the comments or sends it as a message, will get a reward. Isn't that fair enough? But you have to explain entirely why it's random and not systematic, or why it's systematic and not random.
Hey, what if someone Googles the answer?
Oh, fine. Googling is fine. What's wrong with Googling?
Okay.
Go and just Google and if you find something convincing, come back and tell us. There's no harm in that. Yes, but isn't it still random? We've got some good debating going on already.
Yeah, man, everyone wants their reward.
No, it's actually not just the reward, but also the entire learning process and the understanding process. That's also a valuable piece of stuff. So yes, I'm leaving this question open to our students to figure out.
Are you going to reveal it at the end of the lesson?
Maybe. Right then. So coming back to random and systematic error, any change in random error or any increase or decrease in random error directly affects precision. The more the random error you have, the more the precision will be affected. Basically, more random error will lead to less precision. And similarly, any effect in systematic error will directly affect accuracy, right? The more systematic error you have, the less accuracy you will have, right?
Okay.
So that's that. So we're still waiting for a convincing answer. So guys, let's see, what do we have in the comments? This is random error. We may delay too long in starting the watch or delay too long in stopping the watch. So we have someone already brought up stuff from Google. Random cause not everyone can start or stop the stopwatch at the exact same time.
See, he's considering the minority.
Minority kemne? What?
Hey man, it's it's night, dark coffee and all that.
I didn't get that.
Not everyone's up to it, man.
Mm-hmm.
কি হয়েছে বলো না random নাকি system এ?
Well, let's see. Come on, guys. Come on. Tell me. And I'm still waiting for a convincing answer from you guys. And I'm
You
getting
guys can
nothing.
do it, man. You have like 1 month left.
But Nestle did go in Google, so she does have a point. But that is not all that I'm convinced with. Come on, guys. Come on. Come up with something. What if I said, like, every person has a delay and that causes a fixed systematic error? What would you say, Tohon?
Well, if someone is intoxicated,
Yeah, right, fine.
so তখন ওর একটু বেশি delay হবে. And what if someone's a trained athlete in starting a stopwatch?
Trained athlete in starting a stopwatch. Sounds like a referee, but all right.
Oh yeah. Hey man, there is a referee.
Mm-hmm. So what would it be? What would it be? Guess I'm wrong. Well, I don't know. I'm Ansad Hamid. Right. Reaction time should be classed under random error because the reaction time is variable throughout different individuals, and reaction time is also altered as time progresses, i.e. same student measuring oscillations may decrease reaction time the more readings he takes. Yes, but you're still left with an error at the end of it, right?
Isn't that just like what everyone's saying?
Reaction time is a random error because the person may delay or be early. Reaction times differ between different individuals, and the error of the person can be considered to be random. I did text you, by the way.
Oof.
Shahriar Zaman. Mark's scheme states random error is an error where experimental values are scattered around the values made by the observer can be eliminated, and by this definition it is random. But yes, Shahriar Zaman, you do bring up a point that I need to discuss with everyone. Thank you for making that point also. How do we define random and systematic error, right? So we define random error as an error which can be eliminated by repeating and averaging, right? This is what we're seeing here, right? So if you basically have multiple values, you can draw a scatter, and the scatter can give you a best fit line. So basically random error can be eliminated, but for that you need more than one value. You cannot eliminate random error using only one value. You need a bunch of values to do that. And systematic error cannot be eliminated until you don't replace the system. Why? Because all of the values shift by a certain amount. Take us now? Right. So yeah, we have a lot of people actually saying random. Mugdha, would you agree with random being the answer?
Yeah, I would say random.
Why?
Then again, একই জিনিসই যে একটা ইন্ডিভিজুয়াল দেখা যাবে ফার্স্টে একটু তাড়াতাড়ি স্টার্ট করলো, পরে একটু ডিলে হইলো. But then again, doesn't everyone have some sort of delay?
Yeah.
দেখা যাবে ডিলেটার ভ্যালু কমতেছে, but it doesn't mean no একটু আগে স্টার্ট করতেছে একটু পরে স্টার্ট করতেছে. I don't know. The system the person is.
You cannot blame a person for being the faulty system, as there is nothing you can do about it, I guess. So it's a random error. Well, that's a point. But then again, because of the person, you do have errors, right? Because the person is taking
and
the reading.
Until you fix the system,
which is basically replacing the person with an electronic timer, you're still getting that same delay. Is it going to be a delay though?
With the person.
I think I'm doing a great job at confusing literally everyone.
Yeah, like যারা শুরু থেকে র্যান্ডম ছিল তো মাথা খারাপ হয়ে গেছে.
I know. I'll tell you this. কখন এখন বলবো নাকি পরে বলবো?
How about we let them suffer for a bit?
Well, yeah, we could make them suffer a little bit, but Judio, that's not a nice thing to do. But yes, I'm really liking this debate thing going on. The delay being considered. Nah, jhogra na take. I think everyone's leaning towards random.
Hey, most people are
true.
going for random.
But yes, I'll give you the final answer tomorrow, right?
In the Come on, say it.
In the next video. Na ki
No.
jani? Ki jani chilo?
Next time in Raphael Teaches.
Next time in Raphael Teaches. Acha Samin Sabha ki dise. It depends on the experiment. If they're part of the system, they're like delaying and releasing a ball or something, systematic error. If they're timing an oscillation or something, it's random, I think. Yeah, systematic errors can be removed by calibrating reaction time. Can be calibrated, lul.
What can be calibrated?
I don't know, but really interesting. I'm loving this. I'm loving this. How people are actually trying to, like, you know, come up with differences. I never thought students could be so constructive in their arguments. Next video, next episode, everyone losing their, oh my, ooh. Like, you know, I'm making people,
Hype.
I'm making people really unhappy.
You know, you're gonna.
Sorry guys, I can't tell you now. You'll have to find out tomorrow. And what do you guys want to study tomorrow, next class?
Yeah, that was lovely.
Guys, any opinions about what you want to do tomorrow? I'll tell you about reaction time, obviously, but other than that, what do you want to study? Yes, hype. Yes, Mugdhu's my hype man. Akhon bolo, please. No? So why don't you guys give me a convincing answer first? Come on, guys. What do you want to study tomorrow? Questions.
Please.
People are losing it, man. Oof, that evil laugh. You want to hear evil laugh? Like, Waves MCQs. Na, ekhoni bolo.
Isn't she in O level?
Yeah, and she's actually in grade 9. Alright, we have electricity, we have waves. Alright guys, we're going to do waves questions tomorrow, alright? We're going to specifically focus on wave interference, and we're going to talk about superposition and stuff. And to that, we'll also talk about random and systematic error. Alright, Kirchhoff's law, no, Young modulus, long modules. It's actually Young modulus. We'll do extension in a bit.
Wait, say it again.
What?
We'll do that in the, yeah.
Yes. We'll see you in the next class.
Off, go.
Raphael Teaches.
Yeah.
Yeah. All right, guys. Yeah, we'll do waves tomorrow. I guess that's fine. And we're also going to be talking about the answer to today's question. People are just
we
losing
say it,
it.
you know, at the end of next class.
Oh, end of next class. All right, that's even worse, man. End of next class. Take care, guys. Good night. Be good. Don't freak out or anything. Hold your stuff together. Good night.